Well, hello everybody. My children have left because they thought it was annoying and weird. So, okay, this is the answers to the atomic radius ranking portions. Remember, the same two answers to every single thing in this entire unit is that as you go across the period, the most significant change is the increase in effective nuclear charge. Do you hate my voice saying that more than I do? I don't think so. All right, as you go down a family, what is the most significant change? The atoms get bigger. How come they get bigger? Because the valence energy level increases each time you sort of go to that next period, right? Right. All right. So, here, using the placement of each element on the periodic table, rank each of the main group elements in order of decreasing size. Okay, that's just talking about the main group elements are the 1, 2, 3, 4, 3, 2, 1. Oh, now let's do that with feeling. 1, 2, 3, 4, 3, 2, 1. Wait, no, what am I talking about? Those are the charges that they get. This is group 1, group 2, Group 3, Group 4, Group 5, Group 6, Group 7, Group 8. The transition metals are not part of what we would call the main group elements. Anyway, that isn't answering the question, but it is making sure that the children don't want anything to do with me. All right, so, all right, let's start here. Calcium, magnesium, strontium. Okay, so in decreasing size, again, I think it makes sense to use the greater than, less than things. I don't know if you can read those there. I made them light. I don't know why. Okay, so strontium is going to be bigger than calcium, which is going to be bigger than magnesium. How come? Because the valence energy level for strontium is level 5, for calcium level 4, for magnesium level 3, which means that that outermost electron is going to be closest for magnesium. All right, what about potassium, gallium, and calcium? No. Yes. Okay, so what did we say the most significant changes as you go across the period? Increase in effective nuclear charge, Mr. Gorin. Yeah. All right, so when you go from potassium to calcium, how is that increase in effective nuclear charge going to affect the size of those atoms? Well, think about it. If you have that magnet in the middle, that nucleus that's pulling in on those electrons, if you increase the strength of that magnet, what is it going to do to the electrons? It is going to pull them in tighter. So calcium is going to be smaller than potassium. Gallium is going to be smaller than calcium. So the order I get is, now it is illegible. But potassium is bigger than calcium. Calcium is bigger than gallium. All right, what about this? Rubidium, calcium, and strontium. Well, let's compare one at a time, all right? Rubidium is going to be compared to strontium. Well, as you go across the period, what is the most significant change? The increase in effective nuclear charge. So strontium is going to be pulled in a little bit smaller than rubidium, okay? Now, strontium is also bigger than calcium because its outermost energy level is 1 higher. So rubidium is bigger than strontium, which is bigger than calcium. That's why you get that. Now, bromine, rubidium, krypton. Here's rubidium. Here's bromine. Here's krypton. You may say, how the heck am I supposed to compare those? They're different groups, different energy levels, different period. Oh my gosh, that's crazy. Okay, well, let's look at it this way. Rubidium compares how to potassium? It's bigger. How come? They're in the same family, and as you go down a family, what is the most significant change? Bigger atoms, higher energy level in the valence shell. So potassium compared to bromine, potassium is way bigger than bromine. How come? Because as you go across the period, the most significant change is the increased effective nuclear charge. So bromine is going to be pulled, that outermost electron is going to be pulled in way tighter than potassium. So krypton, smaller than bromine. So rubidium is bigger than potassium, which is bigger than bromine, which is bigger than krypton. Okay, so that's what I get for this. Okay, now, one last thing. If you're saying as you go down a family, doesn't the number of protons increase? The answer is yes, it totally does, but it's not the most significant change, okay? They're competing factors that the atoms get bigger, and as you're saying, like, well, you're not saying anything. But yes, it's true that there's more of a nuclear charge, but it's not as effective because the atoms are bigger.